Hello everyone. Today we will learn how to apply seismic loads to our structure. So we are going to work on our previous bridge model with super and substructure. So please load your model, and you will see it on your screen like this model I have here. So for seismic analysis, firstly we normally do a modal analysis to access the modal properties of structure, mode shapes and frequencies, and after that we will do spectral analysis, and finally I will show you how to do linear time history analysis using ADA. So to start our modal analysis, first thing that should be done is defining a mass load combination for our model. So to define this mass load combination, we can go to loads, load combinations, and definition. So here, if you remember, we had different load combinations for our other load cases. So here at the bottom, I will add a new one. I will name it as mass. And for the status, you can drop this row down and select mass. So ADA will recognize this load combination as mass, and then we can go to the other tab here, load factors, and here in the mass load combination you can add whichever load case that you want to be considered in modal analysis. So here I'm going to use the asphalt as my mass, the barrier load case, the dead, the deck or the concrete from deck mass, and the weight from the steel members. So as you see here, you can modify the load factors also. So for this example, I'm just going to use this load combination. So click OK. So next, we can go to our modal analysis icon here. So just click it. Save project, yes. And here in this dialog box, which is the modal analysis dialog box, here in this part you can see the properties of structure, number of members, elements, other stuff. Here we are going to define our mass load combinations. As you see here, it's already defined. So we define it as mass. To perform modal analysis, you can always limit the degrees of freedom. So you can have the horizontal modes or vertical modes only. So here I'm going to use just no limitation, so we are not limiting the degrees of freedom. And also here you can select or choose how many mode shapes you want to calculate or to be calculated with ADA. So let's go for this model with 10 mode shapes or 10 modes. So if you click analyze here, ADA will start to do the analysis, modal analysis. And as you see here, we have the calculation is complete message. So click close. And here automatically the view mode shape results icon here will be activated, and as you see we have 10 mode shapes which is calculated. So if you can just go to activate this drop down and mode shape 1, if you go to view options or by pressing O, in the results tab let's check for the deflections for strong axis and click OK. So if you increase the diagram or the size of diagram, you will see that this is our first mode shape. And if you want to access the second one, you have the second one like this. This is the second mode shape. Third mode shape here. And if you remember to rotate or dynamic rotate the model, you can always use Shift on the keyboard and hold the mouse middle button. So if you just hold these two keys and rotate or move the mouse, you will rotate your model. So this is our third mode shape. This is the fourth one, fifth one, and sixth one, and etc. So this way you have the deflection results for your modes, or you have your mode shapes. You can even you can animate them. So if here I just select the mode 1 again, and here as you see we have an icon as animation, so just click it, and here you can modify the time interval or number of images. So I'm keeping these as default. If you click this run button here, as you see you will have the animated results or animated deflection of my mode shape here. And you can do the same for a second mode shape also. So just select mode shape here, click the animation and play or run. And as you see here, this is the second mode shape of our bridge. You can also access all of these results from results menu here. So you can go to results, and here in modal spectral you can have the frequencies for each mode. So we have 10 modes here, and here you have all of the required data for our mode shapes, the frequencies, the period or damping and others. Click OK, and also you can access results, the node displacements. For this mode shape. So these are the results that you can access or you can check from your modal analysis procedure. And the next step is to perform the spectral analysis. So before doing a spectral, we always need to do the modal analysis. So to define the characteristics for our spectral analysis, you can go to File menu here, File, Project Configuration, and in Seismic tab here, if you use this drop down button here, based on your version, you can have S6 2006 or S6 2014. So here I use S6 2014 code for my Seismic. And here you can have the dialog box based on S6 2014. Here you can choose the importance category of your bridge. So let's define it as a lifeline. It's a regular bridge. Here you can select the spectrum that you are going to use. So you can have 2%, 5%, or 10% of probability. So let's use 2% here. Here this is the site characteristics value. So in this example, I will use site category C, but if you use site category F, you can enter the F values here using this 3 dots icon here. So here you can manually define the F values for your site coefficient. So here let me use the C type, and also here in this part you can use ADA's library for the spectrum. So if you choose your city here, let's go with Ontario, Toronto, ADA will automatically load the spectral values from its library for this town. So we have almost all of the cities in Canada covered. And after defining this value here, in this third section here, you can choose the modal combination that ADA will use for spectral analysis. You can use SRSS, CQC max speed, or CQC minimum memory based on the hardware of your computer. So here I'm going to use CQC max speed. We will have P delta inelastic effects here, and also the levels will be defined as center to center of floors. I will show you how to define those later on. And let's leave this also as default, so rounding for levels will be 0.1 meters. So if you click OK here, you have defined the spectral properties or spectral analysis properties for your model. The next stage is to define your seismic levels for this structure to calculate the spectral forces. So to define each seismic level, we can just select a node from that specific level and assign it a seismic level. So for this bridge, we can use this node at the bottom of column for a seismic level, the first level. So just select the node, double click it, and here in this check mark, just put the check mark here. So this level will be assumed as a seismic level. Click OK. Also, if you want, you can assign this node also another seismic level. So double click OK. And here I will use this cap beam level also for my top level of seismic or spectral level. So just double click again this node here, which is a node from our cap beam or top of the columns, and define it as seismic level. Okay, so here I will have 3 seismic levels, and the deflections will be calculated based on these levels for spectral analysis. Next stage in spectral analysis is to define our directions. So to define the directions, you can go to Loads menu here, and down here we have seismic directions. Go with linear, and in this dialog box we are going to define our seismic directions for our spectral analysis. So just add a row here, clicking this plus sign. Let's name it as X direction. So because this direction is X direction, here I will put 1, so my direction will follow the global X, 0, 0. And here, as you see, ADA automatically chooses the governing mode shape for this direction. Here you have other properties of weight of structure. We don't want to use calibration here, so just remove this check mark here. And also I'm going to add a second direction, a horizontal direction in my global Z. So just I'm going to name it as Z direction. And here you can put 1. So here I have defined my second direction of spectral analysis, and the envelope column that you see here is for results. So we have 3 envelopes available for results of spectral analysis. It can be 2 horizontal and 1 vertical. So I'm using envelope 1 for my X direction, and here I'm going to use envelope 2 for my Z direction. So remove the check mark here. Our R value will be 1, which is the ductility value or behavior coefficient of the structure. So as you see here, we have defined our 2 seismic directions for spectral analysis. Click OK. And next stage is to just run our spectral analysis. So as you see here, you can use this icon, spectral analysis, or either you can go to analysis, spectral, click. You need to do a modal analysis before spectral. So let's rerun our modal analysis. Click here, save your project. Okay. Use the same mass combination as mass, and click analyze. So the modal analysis has been completed. Click close, and now you can do the spectral analysis. Click it and click analyze. So spectral analysis is started, and as you see here in both directions, I have 99.1% of mass participation. So our results will be fine. But if in any case you see that the structure is not reaching that mass participation, you need to define more mode shapes in your modal analysis. So you can go with 20 or 30 depending of the mass contribution that you want to use in your spectral analysis. So as you see here, I have the message, the spectral analysis is completed. Click close, and here you will have the results for the spectral analysis in Z direction, and also you can have it in X direction. You have the maximums and minimums. So for example, if you want to check for maximum and minimums forces on this node or support, you can just go to support mode and double click. So here you will have the spectral forces in this support, minimum and maximum. and also you can access the deflections here, minimum and maximum, the deflections for this node here. If you want to check for internal forces for seismic direction X, you can go to member mode here and double click your member. So let's say we want to check the internal forces for this column, double click. So here you will see the internal forces for this column, the minimums and maximums based on a spectral analysis in X direction, and for Z direction you can drop it down, select Z direction and double click the column to have the results for Z direction. And you can also check for the spreadsheet results here from results menu. So here I have mode spectral. So if you go to levels here, you will have the information for all of the levels that we have defined. You have the height of level here. You have the shear forces, the weight, and the average and maximum deflections due to spectral analysis in X and Z direction. You can also access the drifts here, which mostly we use in buildings. You can also have the results, spectral results for your wall elements here. So if you go to view options by pressing O, remove this check mark here, go to finite element results, and let's go with sigma maximum. Click OK. So here you can also have the results of your finite element plates based on seismic Z direction or X direction. And it's also, if you rotate your model, you have the results for finite element plate here. If you want much more refined graphics or refined coloring on your finite element plates, you can use this icon here, scaling for intervals. This is just for finite element plates. So if you click it, you can, here you can change the number of colors that has been used. So if you go, let's say with 225, you will have much more refined colors on your finite element plates. So this was how to perform spectral analysis on a bridge or on a structure in ADA. And also today I will show you how to do a linear time history for this structure. So to perform a linear time history, again we need to go to project configuration from file menu. So just go to file, project configuration, and here in this bottom part we are going to define our parameters for time history analysis. So the first one is the accelerogram. If you click this icon here with 3 dots, you can use ADA's library of different accelerograms. So in this example, let's go with an accelerogram of El Centro earthquake. So let's go with this one, 9040, 0.25 G. So if you click it here, as you see, ADA will load the accelerogram from that specific earthquake record. You have the maximum acceleration here and maximum displacement and other data for this accelerogram. So let's select this one, click OK. This is the duration of time history analysis, so let's use 20 seconds. This option will help us to have the displacements of nodes saved, so put the check mark here so we can have the results from nodal displacements. This is a time pitch, so let's leave it at 0.01, and here you can enter the maximum acceleration, so let's put it as 0.2 G, and for the vertical also same. So as you see in this window, I have defined the time history analysis properties for this project. If you click OK, and also because after time history analysis we will need the results from nodes, and if we want to results from all the nodes, it will be very heavy analysis, and ADA may use much more space or calculation time. So to have results of time history for just specific nodes, we can always define a selection. So let's select two nodes to have the results, the time history results afterwards. I'm going to select this node here on the pile cap, go to node mode here, select this one, and also let's select another node on the main beam. So just hold Control and select this node here. So as you see down here, I have two nodes selected. If you remember, press Control L to define these nodes as a selection. Control L. And let's name it as time history. Click OK. So right now that we have defined our nodes, we have defined our accelerogram. Now we can perform our time history analysis here. Before time history analysis, we need to perform again the modal and spectral analysis. So let's click here, modal analysis, save project, yes. Okay. Click analyze button. Close, and let's perform the spectral analysis again. Analyze. Okay, close, and now we can click on time history, so click it. In this drop down, let's select our predefined node selection, so it was time history here, and click analyze. So as you see, the analysis has begun. So as you see, the time history analysis is now completed, so click close. So if you go to this drop down, you will see that two other directions are added here. So the first two were the spectral, and the second two are our time history results, X or Z direction. So you can access again your results from here for finite element, and this is for Z direction, or you can go to view options for deflections here. Okay, so if you adjust the size of the diagram, you will see that we have the results. It's a maximum or minimum results from time history analysis in Z or X direction. Also, you can have internal forces with going to member mode, double click the member. So these are the internal forces coming from ET01 or time history X direction. We have the maximums and minimums. If you want to access the results for the supports, you can go to support mode here, double click, and these are the results, maximum and minimum. If you want to check the results coming from deflection of finite element plates, you can go to view options, press O, FE results, and here just put the check mark here for deflection and activate this mode here. So click OK. So you will have the deflection results for your plates also. For X direction, time history, or Z direction. Okay. And also, if you remember, we have defined two nodes to check for the nodal displacement. If you want to check those, you can first check the node number here. So just go to nodes mode, double click, it was 3001, and if you go to results, time history, and node displacement versus time, if you put here 3001 in X direction, or it was the other one, the other side. Okay, yeah. Click the node 3002. Okay, go to results, time history, nodal, and 3002 X direction reading. So here you can see the displacement versus time curve or behavior of this node in 20 seconds during this time history analysis. So the yellow one is your Y direction, and the blue curve is your X direction. You can change it to time history results of Z direction here, so reading. And this is the results coming from Z direction for this node. you can have all of these results as spreadsheets. And here you have the maximum and minimum results for this node. Also, you can compare two nodes. So these two nodes should be already defined as our group or selection. So I'm going to hit cancel here. Go back to our selection. Control K. Time history, okay. Mask and Control H. So one node number was 3002, the other one was 85. So just enter those values here. 302 and 85 for the middle span. X direction reading. So as you see here, you can compare also the results coming from two nodes, and here you have the difference between those in X direction and Z direction. And this is the spreadsheet format. And if you hit D or unmask, you will have the structure here. So as you see, we have defined our tree seismic analysis. We have done a modal, spectral, and time history, linear time history. Right now we have all of those results available in our model. If you want to add or assign these forces into your load combinations, design load combinations, it is possible. You can use our load combination generator in ADA. So if you remember, if you go to structure mode here, if you go to loads, load combinations and generator, here we had some envelopes for spectral and time history envelopes. So because we have already performed these analyses, the results are available for ADA. So you can put just check marks here for spectral envelopes and also for time history envelopes. So ADA will automatically generate load combinations, including these values coming from seismic analysis. You can even put the check mark here for nonlinear time history if you have one, and click next. Also here you need to check this here, so you will have the combination of seismic envelopes in two directions. And if you click next here and check for the load combinations, you have all of the cases here, and as you see here, we have all of the load cases covered. And if you go to ULS5, for example, you will see that ADA automatically will generate these load combinations, which includes all of your earthquake forces coming from either time history or spectral analysis. And if you click finish, you will see that all of the new load combinations Due to earthquake forces is already applied to the structure. And after that, as you remember from our previous sessions, you can just perform the steel design on the structure. Okay. So this was a short session on how to apply seismic forces on a bridge or on a structure in ADA. So if you have any questions, please let me know using our help about and our tech support email here. And I hope you have enjoyed this session today. Thank you very much.